BC classes, the RestBridge and Barista. In this section, we will learn about BC classes. They can be used to provide an API layer for your application. There are multi-purpose use, so you write them once and you can use them in many places. From these many places, we will have an extra focus on the BBJ RestBridge plugin that allows you to provide a RESTful API for your application. And then we will close this section with looking at Barista and how it now generates BC classes for you. But let's first look at some terminology. An API stands for Application Programming Interface, and it's a concept to encapsulate non-UI business logic for the usage not only in a UI but by many other consumers. Business components is a term coined by Basis, and it's a pattern to implement APIs for the Basis ecosystem. Then we're looking at REST. That stands for Representational State Transfer. It's one of the go-to standards for current web services implementations. And then Barista is the Basis data dictionary-based rapid application development framework and toolset that can accelerate the application development also for you. The situation today in many applications is that you do not only need in your own programs to access data and logic, but also in other places. So whereas the data entry is very often the first program being developed, you will soon need to create reports and printouts. Your users will demand dashboards and business intelligence. You may add mobile applications, and your users sometimes export the results of their work to spreadsheets. The problem now is different consumers duplicate the same logic. For example, imagine a situation where you have discount formulas that are in your BBX data entry programs, in the sales order entry, for instance, but then you would need to replicate those also in your Jasper reports to print out a list of the daily sales register, on invoices, and in your dashboard routines, and maybe in many more places, even sometimes in customer-specific implementations. The problem now is that whenever you upgrade this logic, you need to upgrade all those places. At the same time, you risk forgetting some spots. The solution: add a single API layer that all your applications consume. So your data entry programs would, instead of manipulating the data directly, talk to that API layer, as well as the reports, as well as the dashboards, the mobile apps that you may create later, and the export to spreadsheets can also be managed through this API layer. So you implement your logic once in the API and then never again repeat yourself. In order to come to your API first strategy for BBJ, you would need to implement your logic in a reusable way and then consume it from every single consumer and user interface. By doing so, you may facilitate the growth of the ecosystem around your core application and really make it easy to add new functionality as soon as the API is there. The BC classes are a design pattern for BBJ classes that you implement with your own logic. You follow a standardized pattern, and because of that standardized pattern, BBJ can serve your data and logic to all BBJ programs, but also to Java programs that you may write, to ODBC and JDBC through SQL, to REST clients using the RestBridge plugin, which we will have a look a little later. And also you can generate documentation for your API using tools like JavaDoc or Swagger. So thanks to that standardized pattern, BBJ can serve your data not only as BBJ variables, but also in various formats like JSON, XML, Excel, Jasper data source for Jasper reports, CSV, HTML, and even a few more. Let's have a look at the concept. On the left, you see what you probably do today. Use BBJ to implement the logic and then build the user interface for character-based, GUI, BUI, or the new dynamic web client using one of the BBJ thin clients. After introducing the API first strategy with Basis business components, You add an API layer on top of your logic that can still serve BBJ itself, but it becomes available to other technologies like reporting and BI tools, environments for web and mobile development, and many more. The RestBridge plugin will be useful to serve your API to those technologies that do not run inside BBjServlets, while integrated tools such as Jasper Reports will access your API layer directly for optimal speed. We have also prepared a generator for documentation in Java Doc and Swagger format for your APIs based on BusinessComponents BC classes. Implementing your first BC class is not hard. You follow the Java interface BasisComponents BC business component, and for reading, you implement a few methods like retrieve, set filter, set scope, or set field selection. There are a few convenience classes that provide shortcuts. For instance, if your BC API class should be based on an SQL table. SQL Table BC is a base class that abstracts most of the dull work for BCs that mainly build upon an SQL table. You extend this class and put your own code that, for instance, calculates custom columns or that add validation logic for writing and deleting. You can also add searching with Lucene in that class. Let's have a look at a simple example. The CD Inventory BC class is based on the data in the CD Inventory database, and it's written using the SQL Table BC. We see the CD Inventory BC class directly extends the SQL Table BC. By doing so, many of the methods that you would need to do to retrieve the data, to set filters and so on, are already given to you by the SQL Table BC, and you do not have to do much more. The only method that shows a little bit how to add custom code is the retrieve method. In this method, we're introducing two additional fields that calculate on the cost and on the retail value, multiplying it by the quantity. This is a pattern that is used very often to add custom logic for certain fields, for instance, tax calculations in order lines or many more cases. Now we can conveniently use this class from our BBJ code. We use the retrieve method to retrieve the data. We use setFilter to specify filter conditions, and methods like setScope or setField selection allow us to define the desired fields for the query. Write and remove are already implemented for us thanks to the SQL Table BC. A program that makes use of the CD Inventory BC we just wrote may look like this. We instantiate the class in line 4, then we set a filter condition. For instance, in this case, we query all the data based on a recording type. We set the filter, and then we use the retrieve verb to retrieve the result set. And here we use an iterator to iterate the records that we have obtained from the database that has been enriched by the retrieve method custom code. Here's the output of our class. The BC classes can be used in your own code as seen in that simple example, but they nicely plug into tools and other plugins provided by Basis. The BBjGridExWidget consumes result set structures which are returned to you by the retrieve method. Result sets can also directly be passed to Jasper by using the JR data source adapter. Or you can export result sets from BC classes directly to Excel and some other formats. This sample shows how to populate the BBjGridExWidget with the result set that is returned to you by the retrieve method of the BC class. We again instantiate the class, use retrieve, and then we simply use the grid's setData method to pass the result set, and the BBjGridExWidget does the rest for us. Here we have a nice output of our data in the grid. In order to feed the data into Jasper Reports, we again use the retrieve method, and then we use the JR data source adapter to convert the result set into a data source for Jasper. We use Jasper's fill report method to fill the report that we have prepared before with the data structure we have obtained. Then we simply create a PDF file with our report output on disk. In the second part of the program, we use the BBjDocViewer plugin to show the PDF in a BBjDocViewer window. And voila, here's our report filled from the BC class directly. As a last quick example, I'm showing you how to export a result set you have obtained from a BC class directly to Excel. Again, we see the retrieve on top, and then we use the write XLSX method from the result set exporter to convert the result set into an Excel file. And then the last statement opens the Excel file through the BBJ thin client. So BC classes are universal. We have seen how a BC class can deliver your data to BBJ programs, the powerful BBjGridExWidget, Jasper reports, Excel, and there are some other formats supported. But there's more. A BC class can be published as a REST web service using the BBJ RestBridge plugin. In order to install the RestBridge plugin on my disk, I start the plugin manager from the Start menu. Under Available Plugins, I select RestBridge, hit Install, and let the plugin manager do the installation. Selecting the RestBridge plugin under the Install plugins enables the Configure button that brings up the configuration dialog. Here I can add first a context, give it a name CD for our CD store sample BC. As a next step, I create a so-called endpoint in the context. An endpoint is a URL schema under which the RestBridge will receive HTTP requests. I set the working directory to the directory where our sample BC class is saved and select the authentication program that comes with the RestBridge plugin that implements basic authentication against BBJ authentication. You can override this authentication program to fit your own needs. After hitting save, we have configured everything and can verify what has been configured for the context in Enterprise Manager. In the CD context, we see that everything has been prepared and we just have to start the context for the first time. The newly configured RestBridge plugin answers under the URL pattern /cd plus the name of the BC class, in this case CD inventory. The authentication dialog that pops up is developed against BBJ standard authentication, and we see the data from our BC class in the browser delivered in HTML format. We can add additional query parameters in order to filter the data, in this case on the recording type, or we can add additional parameters, for instance, to get the data in JSON format. If you're a Barista user, you can have Barista do the work of creating BC classes based on its data dictionary for you. The BC classes generated by Barista support queries, read, write, and delete operations. They plug nicely into all the use cases for BC classes that have been shown in this session. A base class is automatically created by Barista, and on top of that, you will find an empty skeleton of a derived class where you as a developer can put your custom code. This is similar to call point code, just in the backend and hence reused by all consumers, not just Barista forms and grids. Let's have a look how to configure the RestBridge with Barista's example application. I have Barista on my computer and synced the examples application so that I can use Barista to look at the data of the EXM customer table. I start the plugin manager again to reach the configuration screen. I create a new context for Barista. Add a separate endpoint for receiving the incoming HTTP requests. And then I configure the endpoint for Barista's specific needs. The config file needs to be Barista's config file. The authentication program is the one shipped with Barista since current versions. And the working directory needs to be Barista's home directory. After saving and starting the context, I can again use my browser to query the data from Barista's EXM customer table. Authentication is with Barista credentials now. And here's the data that you can query and manipulate using REST. We have seen that with the BC classes design pattern, you can consolidate duplicate code in one place and plug it in whenever and wherever you need it. You can use your Barista data dictionary to get the initial set of BC classes generated for you. And by doing so, maintenance will be far less error prone and simpler. It will save you time and money. It will future-proof and expand your application logic and make it accessible for the next generation user interfaces and client programs. The BC class concept is an important concept to bring forward your existing BBJ code as well as to write new functionality from scratch. Start your API first strategy today.
In 2021, Basis introduced a new servlet implementation called BBxServlets for BBJ21. BBxServlets were designed to offer better performance, better license handling, and an overall easier configuration experience than their predecessors, BBjspServlets. A major consideration in designing BBxServlets was developing a simple path for conversion between BBjspServlets and their BBx counterpart. The goal was to allow users to migrate servlet implementations with the fewest code changes possible while maintaining the core functionality of the servlet. In my previous presentation, I briefly touched on how you could simply change the BBJSP servlet context, BBJSP web request, BBJSP web response, and BBJSP web session to convert a simple BBJSP servlet into a BBx servlet. This ease of migration is illustrated here with this simple Hello World servlet. As you can see, all that was changed were the object declarations for the servlet context, request, response, and session, and now we have a working BBx servlet with the same functionality as the simple BBJSP servlet. But not all projects are this bare bones. So, what would be required to migrate a larger, more complex project? For this presentation, I want to answer this question by showing the steps I took in the process of migrating a large, multi-file BBJSP servlet-based project, as well as talking through some of the challenges that I faced. By the end of this presentation, I hope you have a better idea of what's involved in migrating your BBJSP servlets, how to address some issues you may run into, and how BBJ22 makes the process much simpler with some fixes that I made along the way. So let's talk about what I'll be migrating. I decided to work with the RestBridge plugin, which you may remember from Stefan's presentation earlier. As a quick summary, the RestBridge plugin is a BBJ plugin that allows you to create RESTful Web Services using BBJ. Conveniently for our purposes, the RestBridge plugin not only uses BBjspServlets to serve its content, but also uses the BBJ admin API to configure these servlets. The relative complexity of this project, along with the use of both the request handling and configuration sides of BBjspServlets, makes it the perfect candidate to explore the intricacies and edge cases of migrating servlets. The first step I took in migration was to follow my own advice from the previous presentation on BBxServlets. I did a search for declarations of BBJSP context, BBJSP web request, BBJSP web response, and BBJSP web session. I then replaced these declarations with their BBxServlet counterparts, BBxServlet context, BBxServlet request, BBxServlet response, and BBx web session. Replacing these objects completely covers the request handling side of the servlet, aka the part of the servlet that's encapsulated in the service method. If this was a basic servlet that only handled incoming requests and served out responses, this is all that it would take to migrate it. However, as I stated earlier, the RestBridge plugin also programmatically configures the servlet through the admin API. As you can see here, when you configure a servlet through the admin API, you call an add servlet method, on the BBjGridE context configuration object. This adds the servlet to the context that was selected. These add servlet methods then return data structures that contain all of the configuration data for the servlet. For the add BBjspServlet method, an object called BBjspServlet configuration is returned. And for the add BBxServlet method, you get an object simply called BBxServlet. These configuration objects allow you to retrieve and set data such as the source file, the configuration file, and the URL the servlet will be mapped to. Notice here the slight differences in parameters between the add BBjspServlet and add BBxServlet methods. Spoiler alert, this will come up again later. So the next steps I took were to change the object declarations for BBjspServlet configuration to BBxServlet, and then change the method name add BBjspServlet to add BBxServlet. Changing these object and method names ensure that we are now dealing with the BBxServlet configuration objects as opposed to the BBjspServlet configuration objects. At this point, I also did a quick case-sensitive search and replace for the strings BBjspServlet and BBxServlet. This will cover any other methods dealing with those specific strings, such as remove BBxServlet or get BBxServlet. So with all that changed, I figured I was done and tried to run the RestBridge plugin. Uh-oh. Looks like BBJ has a problem with the add BBxServlet method having the same parameters in the same order as the add BBjspServlet method. Who could have expected that? If we take a look at the add BBjspServlet and add BBxServlet methods, you may notice that not only are the number of arguments different, but they also are in a different order. While all add BBjspServlet methods begin with the class name followed by the mapping and source, the add BBxServlet methods all begin with the mapping, then source, then class name. And on top of this, an added method name string is needed for adding a BBxServlet. You may have run into this problem yourself in your own migrations, and unfortunately for BBJ21 users, the solution to this is a bit tedious. What I had to do was go through and manually remove the class name behind the source file and add the method string, usually service, to the end of the arguments. Additionally, if your add BBjspServlet method includes the path to the config file, you must be sure to add the method name between the class name and the config file. Clearly, this process could be optimized. Luckily, this has been rectified in BBJ22 and up, with the addition of a 3-argument add BBxServlet method, as well as the ability for add BBxServlet methods to handle the argument pattern of add BBjspServlet. In other words, add BBxServlet can now be called if the class name is first in the method parameters, like you see below. Additionally, the add BBxServlet method that takes 4 arguments can handle the configuration file as the 4th argument in place of the method name. The next set of challenges arose from differences in the method names in BBjspServlet configuration and BBxServlet objects. It turned out that the method names in the configuration objects had names that were slightly different from one another, as you can see here. addParam was changed to addParameter, clearParams was extended to clearParameters, get and set config were extended to get and set config file, get source name was changed to get source file, and set enabled was completely removed and replaced with enable and disable. Once again, I went through and individually changed these method names in BBJ22 to streamline the migration process. In BBJ22, BBxServlet configuration objects now contain the same methods as BBjspServlet configuration. However, if you're still running BBJ21, you may need to change one or more of the following method names. Now that I resolved these issues, I went back into the configuration for the RestBridge plugin, configured an endpoint, and hit OK. Everything seemed to work, but just to make sure, I went to the jetty.xml to see if the RestBridge plugin successfully published a servlet. The servlet was published successfully. All that was left to do was to navigate to the servlet mapping, and bam, there it is. So what are the takeaways from all this? Well, I found that while the execution side of BBjspServlets could in fact be easily migrated by changing the servlet context, web request, web response, and web session to their BBxServlet counterparts, the configuration side of the equation posed a little bit more of a challenge. The mismatch in argument patterns in the add servlet methods made it a tedious task to go through and manually change the ordering of the mapping source and class name. An equally tedious task was to change the method names between the BBjSP configuration and BBxServlet configuration objects. BBJ21 still poses these issues, but the changes made in BBJ22 have alleviated these problems, making the migration process significantly easier. To reiterate, in BBJ22, migration between BBJSP and BBxServlets is as simple as changing the aforementioned service method objects to their BBxServlet counterparts, replacing the BBJSP servlet configuration object declarations with BBxServlet configuration objects, and then doing a quick case-sensitive search and replace between BBJSP and BBxServlet. I hope this was helpful to all of you who are using BBjSP but would like to take advantage of the benefits of BBxServlets. Be on the lookout for an Advantage article outlining the contents of this presentation. Thank you for your attention, and I look forward to answering any questions you may have.
Let's have an updated look at the BBjGridExWidget. I will now revisit what the BBjGridExWidget is and illustrate the optional enhanced license you can obtain for it. I will give you an overview of new features that have been added recently and close with why we think the BBjGridExWidget should be relevant to your work with BBJ. The BBjGridExWidget is a plugin that adds a feature-rich, user-friendly data grid to BBJ. If you're unfamiliar with BBJ's plugin concept, visit bbj-plugins.com to learn more. The plugin comes with demos that illustrate both the features and functions as the user sees them in your application, and at the same time the code behind these features. With these demos, you can quickly get an idea how to use this grid plugin in general and how to implement specific features of it. When you install the plugin into your BBJ, you can use all its standard functionality as long as your BBJ license is under SAM. Give your users features like filtering, sorting, grouping, column pinning, or column drag and drop with only little additional effort. Thanks to the underlying third-party JavaScript component we have built on, you can add additional attractive features. We at Basis have negotiated a favorable pricing structure with the vendor so that for a small fee of only $5 per year and concurrent user, you enable its enhanced features. It's probably important to mention that the user count for the enhanced grid in your license does not have to match the total user count you have. You can purchase the enhanced functionality for a smaller subset of your users and control by its API who should get the license and who of your users continue to work with the standard version. Enhanced features include ad hoc charting, pivot tables, a tree create feature, and a few more user-centric features to its UI. Let's have a look at a few demos. I have used the BBJ Plugin Manager to install the BBjGridExWidget on my machine. The Plugin Manager allows you to run the demos directly from its UI, but as a developer I will use my Eclipse IDE to look at and start the demo programs directly. The demos directory hosts a number of useful demos that mostly show functionality which is available in the standard version. The subfolder Enhanced adds a few more samples that illustrate features of the enhanced version. Let's look at one of the simple demos, the CD Store. It shows how to populate a simple grid from a select statement. When we run this in GUI, we can see it loading the records from the CD inventory table. The user can drag and drop the order of the columns, sort the data in the grid by clicking on the column header, or filter the data with the filter in the column menu. I have now enabled the license for the enhanced BBjGridExWidget on this computer and started the CD Store demo again. You can see that there are a few new controls on screen that the user can use to work with the data in the grid. The drawer on the right allows the user to switch the visibility of the columns in the grid. The filter panel allows the comfortable definition of combinations of filter settings for multiple columns in one place. The menu for each column has received additional functionality, like column grouping and pinning. I can now pin a column to the left, or I can use the group feature to group by recording type to get a nice structured view of my data. The Filters API demo is written to work in both the standard and enhanced version. When running it with enhanced licensing, it illustrates how to enable so-called set filters on the data in a certain column. A set filter shows the distinct values within that column for the user to select and deselect with an individual checkbox. This feature is known from many spreadsheet applications like Microsoft Excel. Let's look at another one. The charting demo shows how to create charts on the grid. When we run it, we see a chart that is created by program code and overlays the data. The API offers various chart types, formatting, and positioning options. In addition to your programs, the user can also create ad hoc charts directly in the UI. The last demo of enhanced features in this short summary is the tree grid. Other than the grouping of data we saw earlier, you can use the tree grid of the BBjGridExWidget to provide a true independent tree control on the left that controls the data rows on the right. In this sample, we see a file system structure. There are many more enhanced features you may find interesting. Contact your sales representative to obtain your license for the enhanced feature set of the BBjGridExWidget. Since its first release, the BBjGridExWidget has evolved quite a bit. Besides a few minor improvements, it has received two features that I will present to you now. We have added full editing support. Now you can not only use the grid in your queries to browse data, but also for data entry. A second feature we added recently for the browser-based clients of BBJ is the horizontally aligned scrolling of two separate grids, which is fully implemented as a client-side feature and does not produce any server round trips for optimal performance in thin client deployments. There are three programs that illustrate the new features, two for editing, one for the horizontally aligned grid. Let's start with editing. The program editing.bbj shows editing for various data types. I can click into grid cells and start typing. Date fields get their nice date picker, and timestamps add an hour-minute portion to it. Booleans get a slider toggle in this sample, and number input is controlled by the usual BBX masking rules. To the right, we see a drop-down select cell. The orderlines.bbj is written as a potential order entry grid for items from the Chile company sample database. I can enter an item number and a quantity. The quantity column has, for the purpose of demo, a validation to allow only numbers below 10, and you see how the row updates as the user enters data. We're closing with a look at the horizontally aligned two grids, this time directly in the browser in the new dynamic web client. As we can see, the grids control their horizontal scroll position directly based on their own, but also on the scroll bar of the linked other grid. The latest version of the plugin has also received more support for the new BBJ dynamic web client. We have enhanced the grid to load directly in a responsive flex layout with CSS and made the plugin aware of most of the variables that can be defined with the BBJ theme editor, for instance colors and fonts. Let's have a closer look at both. The demo we are looking at is a modified CD store sample program as it comes with the grid. When we resize the window, we see the grid and the controls on top of it rearrange instantaneously without any server-side BBJ code that would do the resizing and relocating before. The demo shows how the grid supports the DWC theming. I can switch between light and dark mode, and the grid follows that toggle. Let's create a different theme. I switch to the DWC theme editor and change the primary color to some darker green value. With the export function, I can save a theme file for use with BBJ's dynamic web client. Back in the grid demo, I select the theme file I downloaded before and apply it. We see that the prior blue color has changed to green in both the light and the dark theme. BBJ cares about proper contrast and calculates the proper derived colors for you, like the color for the alternating row backgrounds in the grid. You have seen that the BBjGridExWidget improves the user experience of your application and comes with a lot of useful features. It performs well, especially in BUI, and makes your life as a developer much easier with its new API that can build directly on the data structures of your application. By upgrading the data grids to your code to the BBjGridExWidget now, you make it ready for the dynamic web client. The BBJ standard grid and its siblings will not be brought to the dynamic web client as you know them from the past. The BBjGridExWidget is the step you can start implementing now, not only to give your users immediate benefit, but also to get ready for the next generation BBJ thin client, the dynamic web client.
Here's to better performance. In this session, I'm going to talk about what is the performance analyzer, what's in a trace file, starting and stopping tracing, as well as the Eclipse plugin for tracing. We're going to talk about making sense of the performance analyzer output, the display, as well as go through some tips, warnings, and options to improve your software's performance. The Performance Analyzer is a utility for analyzing and optimizing the performance of your business basic programs. It helps you identify the source of performance bottlenecks within your code. The Performance Analyzer Eclipse plugin is part of the BBJ Utilities plugin. It's installed with the Business Basic Development Tools, BDT, and overall it's easier to use than the previous utility, especially if you already use Eclipse for your software development. But you can use whichever version you like. Let's look at how all performance analyzers work, and we're going to do that by analyzing a trace file created using the setTrace verb. The setTrace verb writes out information about each line of code as it's executed. So, if we zoom in a little bit, each line of code executed will produce 2 lines of trace output. On the first line of each pair, the initial value that's in square brackets is the line number in the source file. Here, we were looking at line 36. Following that line number is the actual program code for that line. Please note that if you're tracing programs with traditional line numbers, these will not show up with the number in square brackets. The second line of the pair has 2 values about when the execution finished. The first value you can consider a running total of the time elapsed since tracing began. In this case, line 36 of the code finished at approximately 195 milliseconds after we began that trace. The second value in curly braces is the number of milliseconds that elapsed since the previously traced line of code finished. In this particular case, line 36 took about 153 milliseconds to run. There are some considerations that you need to be aware of. First, setTrace is going to slow down your program. There's no 2 ways about it. However, it will slow down the program in a consistent way so it doesn't affect the overall numbers. Second, setTrace can generate very large output files, so that's something to be aware of. In order to minimize these side effects, you should really only trace the code that you want to optimize right now. In addition, you only want to have setTrace verbs uncommented in your code while you are actively debugging or optimizing the performance of your code. The good news is that even just a quick look at the setTrace output can give you really valuable insights into where your code is spending its time. In particular, it assists with debugging branches and loops. So let's look at some BBJ source code that calls setTrace and tells it where to write out the trace file. If we zoom in a little bit, lines 29 and 30 tell BBjServlets to open a channel to the trace file named BBjGridData1.trc. That's going to be put in the current working directory. Line 31 then tells BBjServlets to enable the optional case statement tracing. By default, case statements are not traced, which is a backward compatibility thing. And then finally, line 32 tells BBjServlets to begin tracing. Since the next line, line number 33, is blank, which you can see a little bit on the bottom there, tracing output will actually start with line 34. Now, tracing is going to continue until we reach the end trace on line 84. Stopping here is important because line 86 is the process events loop, and that waits for the user to interact with the system, and therefore it's going to cause some long delays and can really skew your statistics. So we're going to run this BBJ program in Eclipse. We're going to load the file into a new BBJ project in Eclipse. We're going to run it either as a GUI or a BUI BBJ program. It's not going to make a difference either way. And then once the sys console and the UI appear, tracing is going to be complete, so we can dismiss them both. Finally, we're going to open that output trace file in Eclipse. And this is where we really get to see the benefit of the Performance Analyzer. The Performance Analyzer plugin displays the trace file for easy review. You can view this information on 3 separate tabs, either All Statements, with the statements grouped by method, or by the call stack hierarchy. Today I'm going to focus on the All Statements tab because once you understand that, then the other 2 are much easier to understand. This shows each line of code in columns. The line column obviously shows the line number in the source code. The count column shows n, the number of times that that line was executed during this particular trace run. Total is the total time that was used for that line's n number of executions. The percent column shows the percentage of the total time elapsed that was used by this line as it was executed n times. And finally, the statement column holds the source code line that was executed. Each of these columns can be sorted, and if we sort by the line column, that puts the entries in the same order as they appear in the source file. This is very useful, obviously, when you're trying to find a particular line in your source code, or if you're concerned about a particular line in your source code. It can be more useful to sort by the percent or the total column. Either of these will bring the locations where your program spent the largest amount of time to the top of the table. Notice that all times are in milliseconds. If we zoom in a little bit, we can see that line 78 was the most expensive line of code that we executed. It was executed 20,000 times, as we can see in the count column. In the total column, we see that it took a total of 375 and change milliseconds. And in the percent column, we can see that it made up about 6% of the total runtime, 6.5%. In the statement column, we can see that this code does 2 things that contribute to the total time. First, it executes a mod function to calculate a remainder value, and it also makes a call to the GUI function to make a new font. If we look at the average column, that tells us the average execution time across the 20,000 executions of that particular line. In this case, it took about 0.0188 milliseconds, or about a 50th of a millisecond each time that it ran. But we can also see that line 78 consumed a total of over 375 milliseconds because it ran 20,000 times. So really, the important take-home here is doing something tiny. Even if it's tiny, it still adds up if you do it enough times. In these previous slides, you can see that some of the cells were highlighted. The Eclipse plugin, under the Preferences section, allows you to conditionally configure the background and the foreground of the cell colors so that you can highlight values that are most important to you. In addition, there are some ways that you can sort the output to help analyze your program's performance. As we discussed previously, sorting by the total or the percent column can help you find the most expensive lines of code. In addition, sorting by the count column can help you find which lines of code were executed the largest number of times. This is where debugging loops and recursion and things like this become a lot easier using this tool. Finally, if we sort by the percent column, it can help you find which lines of code consume the highest percentage of the total amount of time. Notice that the percent and the total may not point to the same line of code. The Performance Analyzer traces execution time to the line level. So, for more accuracy on a code line with multiple statements, you can break out these statements into separate lines, and that'll give you better insight into what on that particular line is taking up the time. In addition, it's better to do several focus traces, each looking at a discrete task, rather than looking at a large block of code that performs different functions. Finally, we want to focus on tasks that feel like they're taking longer than you or the user expect. So you don't want to randomly go fishing across large parts of an application unless you believe that performance is suspiciously poor. And even in those cases, you're going to get the best information if you break it up into several focused traces. You want to try to trace one conceptual task at a time. Focus on calculations and I/O, especially things with minimal user interaction, because user interactions can add arbitrary delays that can really obscure the actual code performance. Next, if after examining the performance analyzer output, you don't see any entries that have excessively large contributions, then that's valuable too, because you may have just figured out that your program is as efficient as practical. If the performance is acceptable, then you don't need to do anything else. You learned a valuable thing, and now you can move on. If not, this is where it points to a redesign with structurally different logic that may take less time. Filtering the All Statements tab makes it easier to find a specific line of code in a trace file. You can filter the All Statements tab in two different ways. You can exclude specific statements. In order to do that, you add entries to the Eclipse Preferences Filtering tab. The Performance Analyzer will hide any line of code containing that text. By default, as you can see on this page, the plugin excludes all process events lines. Process events being a call to the user interface. Next, you can show only specific statements by entering text in the search field at the top of the All Statements tab. The Performance Analyzer will then show only lines of code that contain that text. So a few warnings. SETTRACE will slow down your program execution, as I mentioned, and it can generate very large output files. Because of this, you want to trace only the code that you want to optimize right now. Second, you want to only place SETTRACE verbs in your code while you are actively debugging or optimizing performance. Third, you can expect your code to run faster without the tracing enabled, and this is why you want to take it out before you hand it off to anybody else. Because of startup overhead, the first run of your code will likely take longer than subsequent runs. This is just the nature of tracing and the nature of software. It's important to do multiple runs and kind of average that information. Next, the end user's perception of client-server performance is going to depend on a lot of things. For example, the network connection between the server and the client. So performance measured with a client and the server on the same computer is really only realistic if your clients are going to run that way. Ideally, you want to trace your program in the same environment your users are going to run. For example, if your users are going to run in a thin client or a remote desktop configuration, then you definitely want to run SETTRACE in that mode. Or if your users are going to run in a browser-based GUI configuration, then using SETTRACE in that mode will give you the best information. Executing several client-side operations, such as setting up a window, followed by an operation that requires a response from the client, can obscure some performance information. In this case, that last call, requesting the information response from the client, may have to wait for all of those other operations to complete. Obviously, this can cause SETTRACE to report an incorrectly large execution time for that backlogged operation. This behavior will produce the best overall performance, but it can be misleading when tracing. Therefore, there is a SETTRACE mode equal flush, which forces SETTRACE to fully execute each line of code before it continues. This gets around that concern. You can use the Eclipse Plugin or the BBJ Performance Analyzer utility to analyze performance. However, there are a few visual and functional differences between them. First and foremost, the BBJ Performance Analyzer shows the timestamp time in the window header, whereas the Eclipse plugin currently does not do that, although that will be an enhancement in the future. Second, the BBJ Performance Analyzer supports listing tokenized source files as part of the analysis process, whereas the Eclipse plugin does not, because of course BDT development relies on ASCII text program files inside of Eclipse. If you're already using Eclipse and the BDT plugin, then the Performance Analyzer plugin will probably be the most convenient to use to optimize your programs with repeated set trace executions. Eclipse relies on file extensions to recognize your trace files. This is very important, so your set trace output files must end in .trc to get the full benefit of Eclipse's project and file management. The BBJ Performance Analyzer does not require a particular file extension or even any extension at all. Once you identify a location in your program to optimize, here are a couple of general options to consider. First, if you don't really need to do it, stop doing it. Look for ways to do the minimum work possible while still achieving your software goals. Second, do it more efficiently. Combine actions, especially those that require round trips between your client and the BBJ server. This is important because you want to avoid round trips to the server. For example, if the information is already available on the client, then don't ask the server for it again. Finally, do it less times. As we saw previously, you want to minimize how many times your code performs actions in loops whenever possible. So, do only what you need to do, only when you need to do it, and as efficiently as possible. In summary, only you can help your users. Running the Performance Analyzer can help you identify the portions of your code that take the most execution time. It may show you what you already expected to see. Be aware of that, or it may surprise you. My experience has been there are usually some surprises buried in there. But only you know and understand the goals of your software, so only you can find the best way to improve the performance of that code.